that most of you are out of town. If you're from out of town, or most of you should be from out of town here, feel free to just do a short who you are and where you're calling from here. You're calling in from today. It's very interesting for us to see who is around all around. With that as well, Katie, do you want to talk about MNBI and what people can do to get on the mailing list?
Yeah, I would love to. Thanks, Jim. Hi, everyone. Thanks so much for joining, and welcome to our February Char Talk. If you are interested in becoming a member, or in case you signed in to join this through LinkedIn, feel free to go to our website, which is mnbiochar.org, and I'll go ahead and put that in the comments for everyone. So you can go ahead and go there and check out all the latest and greatest. We would love anyone that would love to sign up for a membership. We also have various events that are happening that are listed on there and updated regularly. We also have past Char Talks, so you can go there and check out Char Talks that we've done before. And then, of course, again, if you'd like to join our mailing list down at the footer, you can go ahead and just put your email in there. We'll get you signed up to make sure that you are able to join future Tar Talks. And then we also have an email if you have questions. I'll go ahead and put that. It's admin at mnbiocharinitiative.org. And if you have any questions, we'd be more than happy to get back to you. So thank you. Those are the highlights. Appreciate it, Jim. I'll hand it back to you.
All right, thank you, Katie. We recently received our 501(c)(3) status, so this is coming along as an organization. Started out strong, but if you'd like to support MNBI, please feel free to join. We have a lot of members from all across the country, and hopefully getting some internationals. So it's fantastic to see you. And Karina, it's good to see you. I was hoping that either you or John or Kelpie would be here today. But do you want to give a short boost on Boss?
Yeah, sure. For those of you who are interested in learning more about biochar on site, please feel free to go to biocharonsite.org. And we're a community of practice, and we get together once a month. We have a guest speaker every time to share a bit more about either how they do their practice, their story with how they have evolved their biochar on site practices. And it's been really cool seeing both businesses, practitioners, fire professionals, soil folks, and learn more about their journeys. And we'd love to see you the first Wednesday of every month at noon Pacific.
All right, fantastic. Thank you, Karina. I was hoping that I'd be able to give you a shot, and you did a much better job than I ever would have. But we're going to get our presentation underway. Just a couple of notes here as we're going along. Please pay attention to the presentation. Respect the crowd. Please keep your computer on mute. We will find the master button to mute people who are out here. And also, if you have questions along the way, feel free to drop them into the chat. We'll be asking the questions in order received at the end of the chat, as well as having a chance then to raise your hand and ask their speakers directly your questions. But we'll do that after the end of the presentation. And very excited for the crowd we have today, and very excited for our speakers. Thank you very much for coming here today. I'm going to be introducing the three speakers here. First of all, we have Natasha Rosso, founder and CEO. So Natasha is a climate tech and strategic communications leader with a decade of experiences in advancing deep tech, sustainability, and environmental solutions through media, investor relations, and policy engagement. She founded and led startup initiatives, contributed to publications like Inc., and built cross-section networks that bridge climate innovation, carbon markets, and soil health strategies. At Super Biochar, she drives vision, partnerships, and execution across the US, EU, and India. And following is Bluven Ravindran, the co-founder and chief technology officer. Bluven is a mechanical engineer and biochar innovator with deep experience in thermal hydroconversion, pyrolysis, and applied climate solutions, bridging engineering design with real-world deployment. At Super Biochar, he leads technical execution across the platform and product stack, building the systems that connect diagnostics, blend design, and measurable soil remediation outcomes. And finally, we have Dr. Sarah Duarte, co-founder and chief science officer. Sarah is a soil scientist and sustainability professional with expertise in soil health, ecosystems, and a program strategy across climate and agriculture. She has led multidisciplinary initiatives that bridge scientific rigor with operational implementation, from field research to organizational finance and reporting. At Super Biochar, Sarah oversees scientific validation, financial strategy, ensures that our product solutions are grounded in robust evidence and economic discipline. And just a little bit about our Super Biochar. A very interesting talk we had earlier. But Super Biochar is a climate tech company developing engineered biochar blends and an AI-powered soil intelligence platform to remediate contaminated soils, including PFAS, heavy metals, and hydrocarbons. We source from certified U.S. producers, blend with regional specific organics, and use real-time analytics to tailor the right amendment for each site. Our approach improves soil health, boosts yields, lowers input costs, and enables verifiable carbon removal. Since 2025, we are piloting across Connecticut, the Northeast, and select Western sites with partners in agriculture, land restoration, and environmental engineering. We plan to expand to Europe in 2027 and will be piloting in India in 2026. With that, I present you with the Super Biochar team.
Thank you very much. Thank you, Jim, for this really nice introduction. It's a pleasure to talk with you, Jim, about Super Biochar, our work, our understanding about contaminated soil to climate solutions. AI optimized biochar from remediation and carbon removal. So we will start first to talking about how biochar can be a solution for contaminated soil, and after that, how to design biochar to be a better solution and improve the capacity of biochar to remediate soils. After that, you will jump with Bluven, and he will talk more about our tool and how it works. So we can go to the next slide. If you look at biochar itself, as you can see in this image, biochar is a product already done with really nice characteristics that makes it a really nice product to immobilize contaminants. And this is why biochar is so fascinating, because it has these three main properties. Extremely porous, it's like act like as a magnet, and also it's improved the soil pH. Those three main characteristics make biochar a powerful tool to addressing this challenge that is contamination in soils around the world. So let's talk about how porous is this biochar. Look at these images, and then you can see that the biggest part of this biochar, sorry, can you hear me? Everything's okay?
Yes, we can hear you.
Oh, thank you very much. Yeah. So the biggest part in the biochar, we have microporous. Almost 50 to 80% is microporous material. The rest is divided into mesoporous and macroporous. So this is a really nice tool because it makes a biochar a really nice material because it has a huge specific surface area. For example, 1 gram of biochar has the surface area of a football field. Another thing is biochar, when it has in pH between 4 to 9, normally is a net negative surface, which is really good to attract, for example, heavy metals. pH and pesticides stack into biochar carbon rings. So those things really helps to address those problems in soil. Another thing is normally heavy metals precipitate between pH 6 to 7.5. So as biochar, when you added biochar in the soil, which increase biochar soil pH, it precipitates heavy metals, and then we have also this problem, reduce it and immobilize. So of course, biochar alone, we can increase its powers if we added other things such as iron nanoparticle, treating biochar with acidic or bases, or mixing it with helpful bacteria. And now we can go in the following slide to see more details about it. Thank you. So, for example, the first thing is trapping forever chemicals. So what is forever chemicals or PFAS? Toxic chemicals resist to heat, water, oil, and degradation. It is present in no-stick pens, firefighting foam, waterproof clothing. They stick around for decades. So here we have three main points that makes biochar a powerful tool to address this problem. The first one is physical trapping. So PFAS molecules get stuck into the biochar tiny pores. All PFAS molecules are lower than the micropores of biochar. As you saw in the first slide, the micropores of biochar is less than 2 nanometers. So all PFAS molecules are lower than that. So if you added biochar with really huge specific surface areas, such as coconut husk, for example, we will have a direct impact in track these PFAS into the biochar tiny pores. Another thing is electrical attraction. And this is we play with these biochar blends, because here we have, for example, that biochar is negative charge. Okay, so but for attract PFAS, we need to change it to be positive charged. So one of the methods that you can use to do it is, for example, co-pyrolysis with nitrogen, or we can coating with oxide or aluminum oxides or latham compounds. Those things helps to increase the biochar positive surface and increase this positive surface as a final product. Another thing also we can add, for example, acidic, because as we have this, when do we have maybe there is someone with the microphone turned on. If you could please turn off, it will help me a lot. Thank you very much. So the acidic surface will help to reduce this. You help to reduce this pH, and you achieve the point of charge zero when biochar will also increase this positive charge surface and attract more PFAS. Another thing is to grassy tail PFAS sticks biochar in the carbon surface. So light drops clumping together in the water. PFAS normally is more stable, spends less energy if it is
Sorry to interrupt.
in the biochar surface. Yeah, please, Natasha.
Sorry, I was just wondering if AJ Bird could go on mute because we can hear everything.
Thank you, Natasha. It helps me a lot. Thank you, AJ Bird. So, as I was saying already, PFAS is unstable when it is on the soil solution. So when we added biochar in the soil, It's less for them. It's like, okay, they are, before living in a really bad apartment, you are inviting him to live in a beautiful house. Of course, PFAs will accept. And now it's more comfortable when it is together or in the biochar surface instead of in soil solution. As a result, we have that by adding biochar in the soil, we can, and blended it, we can reduce the PFAS problems in 86 to 95%. And here we have an example. For example, this biochar lychee seed is a ligninous material. When we added this zinc chloride, it was immobilized 95% of PFAS versus 40% of pure biochar. And then why this happens? Because when we add the zinc chloride, it increases specific surface area, it increases positive surface, and of course, it was better to track these PFAS inside of biochar pores. We can go to the next slide. Thank you. We also have the effect of biochar in immobilizing heavy metals in oil pollution. So heavy metals we can find in mining waste, in wood, in pipes, in batteries, in contaminated soil. So first, it acts in chemical bonding, ion swap, and precipitation. Let's talk about chemical bonding. As you can say, as you saw, biochar in normal range 4 to 9. So biochar change its chemical surface. Normally is negative when the soil has pH 4 to 9, which is the biggest part of the soil has this pH. That's why it is considered as a net negative product. But you can change it if you lower this pH for less than 4. So we can change it to be positive. Heavy metals has a positive surface, normally is charged in positive way. It's really easy to track it because by its chemical bonding. Another thing is ion swap. This is really nice because normally when we have heavy metals in the soil, in the in the soil solution, for them it's easily attracted by the soil by the particles of this biochar. And these attractions is higher than the soil particles. That's why even if you have biochar in the soil, and of course you have, for example, calcium, magnesium, and potassium that also has positive charges, its attraction, so you can say that calcium, magnesium, potassium nutrients in the soil is more comfortable if it is in the solution than is compared with the toxic metals. For the toxic metals, they spend a lot of energy to be in the solution. They feel more comfortable, for instance, if it is attracted or bonded by the biochar. So that's why in this battle between nutrients and toxic metals wins in be bonded with biochar instead of nutrients. And another method is through precipitation. If we have a soil in pH between 6 to 6.5 to 7.5, the biggest part of heavy metals will precipitate in this pH. And this is really nice because as you added biochar in the soil, and this biochar track this heavy metal through its porosity and precipitating it. If the condition does not change through the time, imagine like 10 years or more, there is a crystallization. And this is beautiful because crystallization is permanent. It means that we immobilize this biochar and this biochar is not available anymore in the system. The heavy metals is not available anymore in the system, sorry. So we can say that biochar alone, we can resolve or immobilize heavy metals in 10 to 70%. and biochar and treated biochar in 55 to 95%. That's why in the biggest part of the things we need to also address and include other inputs such as iron oxide, for example, to immobilize specific heavy metals problems in the soil. For example, Liu et al. In 2024 verified that when in brown seed, this was the pH for this biochar, 8 to 9, 8 to 9. He added iron oxide, and he verified that arsenate was immobilized in 96.7%. Why? Because arsenic look at onto iron oxide surface. They have really attraction between both of them. So it disempower biochar to resolve this problem a little bit faster. Another thing is oil and petroleum pollution. So normally those problems we can find in gas stations and oil spills and industrial sites and contaminated groundwater. So as you saw, biochar act like a sponge, soaks up into this oil, for example, into its porous structure. Also, it also acts as a molecular velcro because forms carbon rings. Biochar stick with carbon rings in oil, and then this one allows this immobilization and does not be anymore available for in the soil solution. And also when we have this biochar into the pores of the biochar, we know that bacteria is a powerful tool to degrade this oil, for example, no? So in simple words, bacteria eat this oil and convert it into water and CO2. So we even can not only immobilize, but using bacteria, you can remove this contamination in the soil. So finally, you have this winning combo. If you added biochar plus bacteria, we can immobilize 6-7% of oil versus 24% if you added only biochar alone. We can go to the next slide, please. Here we have a really nice example. This is our first project in contaminated soil. In Marensa is an island park in Connecticut, USA, close to New York. And this is an area with a huge potential. Since 2020, 90 and 60, they started this contamination with coal. And after that, the pollution with arsenic increased too much. So, but right now they want to revitalize this area. They want to convert this area in an area for people, for animals, where everyone can enjoy. So, and here is the first problem because we are currently looking at the soil properties to address the best solution to solve this arsenic problem to immobilize it. You can go to the next slide, please. So biochar is a powerful tool, not only in terms of contamination, but also in other things. For example, in terms of soil structure, in crop performance, and input efficiency. Look at this. For example, when you added biochar in the soil, it holds water even in 6 times its weight in water. For example, can be less, but this is the maximum potential. Aeration increase. We have also habitat for beneficial microbes. We reduce and prevent soil erosion because, of course, we increase the soil aggregation. And then as a result, we increase the water holding capacity in 5 to 40%. If we are working and improving the soil quality, of course, it will have result in crop performance. We can see results in crop performance in increasing plant yield in 25%. Sometimes they get less or more, but yes. Why? Because we are also increased nutrient availability. The plant also has low stress because increase its resistance to disease, increase this resistance during the drought period, also increase the input efficiency. We reduce the water savings in even 50%. We reduce the fertilizer in 10 to 100%. We also increase the carbon storage in the soil. And of course, because we are reduce those inputs, we increasing the costing savings in 50 to 300 dollars per acre. You can say, sometimes you can say, oh, this number can be so high, isn't it? But of course, normally we added biochar in the first year. Normally we don't not achieve those values in the first year, but it's during the time. As you know, biochar can remain in the soil for thousands of years, and then during after like 7 years, we can achieve those gains or those savings because biochar will continue supplying nutrients for the plants. You can go to the next slide, please. So how AI determines biochar application and blend design? What we do is first to analyze the soil properties. The key parameters, for example, nitrogen, phosphorus, and potassium. We also evaluate the pH level, cation exchange capacity, and organic matter. These are the main package that you evaluate in the soil. After that, you also look at the physical properties in terms of soil structure and bulk density. After that, we assess the crop demands. How much this plant requires in terms of pH, organic matter, NPK, and other things, no? Then we go to evaluate the biochar properties, and then we evaluate the nutrient content, the pH value, the CN ratio, cation exchange capacity, surface area, and porosity. So then we calculate the nutrient gap, this one, and in the step 5, we design the optimal biochar blended. So we have this, through that we choose the how many tons per hectare per acre you needed, plus amendments that can be composed, minor minerals, or nutrients plus microorganisms. And now, of course, this is an example for agriculture, but I also believe we'll talk a little bit more about this tool for contaminated areas.
Thank you. Thanks, Sarah. Before I jump into the platform, I actually want to pause for a second. So Sarah gave us the scientific foundation, which is critical. But Natasha, as our CEO, who's the brilliant brain behind the whole idea, who wanted to frame why we are doing this in the first place, so beyond just the chemistry. So I think it's important the audience hears the perspective before I go into the technical engine. I would like Natasha to speak us.
Thanks, Bluevin. Hi, I'm Natasha Russo. I founded Super Biochar, and I'm the CEO. I'm very lucky to work with Sarah and Bluevin. I understand that many of you already understand the promise of biochar, but what we kept seeing and what we kept seeing on farms, brownfield sites, golf courses, coastland land is that biochar works, but the process around it has been fragmented and it's been very difficult to verify its impact. So oftentimes biochar is produced and applied generally in a very generic form. And the feedstock is often unverified and often poor quality. And when biochar is blended, and when it is blended, it's often pretty inconsistent and doesn't tailor to specific soil conditions. So we decided to develop biochar blends that are very specific to the characteristic of the soil, the region, at the soil composition. And yeah, so my role as the founder and CEO is to, one, make sure that soil regeneration becomes measurable, financially viable, and accessible for farmers and for remediators and communities living alongside these landscapes. But Sarah went into the science, and Bluevin will go into the tech, including the machine learning and the AI. So thank you, Bluevin.
Thanks, Matt, and thanks, Sarah. So I think Sarah just described the remarkable properties of biochar and the ability to engineer it for specific pollutants, the soil health benefits, the carbon sequestration. There is all of the potential is only realized if you apply right biochar in the right form, at the right rate, to the right soil. So the generic biochar applied incorrectly either underperforms or can actually cause harm. So this is the problem our AI platform solves, and the logic is relatively simple, even if the execution is technically complex. Our system runs like a 5-step analysis. First, it ingests the full soil chemistry profile, which is like the pH, nitrogen, phosphorus, potassium, cation exchange capacity, organic matter, and the physical properties like texture, bulk density. The second, it accesses what the target crop or remediation goal actually needs. So if it requires like a particular pH range, nutrient demands, or contamination thresholds. So, and then the third, it evaluates the properties of available biochar feedstocks in our library. So it actually, like, it will be selected based on the pyrolysis temperature ratio, the feedstock type, surface area, porosity, the nutrient content, and the pH. And the fourth, it actually calculates the gap, like what does the soil have, what does it need, and what does the available biochar provide. So the gap equals crop needs minus soil supply. And the fifth, it designs the optimal blend. So that means the selecting the base biochar type and application rate in tons per acre, adding amendments like compost or minerals, including any needed nutrients to fill the NPK gap, and specify microbial inoculants were appropriate. So this is actually not a guesswork; it's a systematic chemistry to prescribe the translation, and it's a kind of analysis that used to require like a highly specialized agronomist or like an environmental chemist take weeks and cost thousands of dollars per site. So what we have done is we have just automated it, and so that differentiates Super Biochar from anyone just selling bags of char. uh, I think we can go to the next slide. Well, I'll take it through the steps of the process. So the platform serves like a two distinct user types. So one is the farmer and the environmental remediators, and the workflow is slightly different for each, but the underlying logic is same. Like what we basically do is remove the fragmentation and the guesswork. So for the farmer, they open the app and enter their field address and crop type. So within like 48 hours, a pre-labeled soil sample kit arrives at their door. So no ordering hassle, no risk of mislabeling. They dig a few soil cores, mix them together in sample bag, and mail it back. So the critical piece is what happens next. We have a direct API integration with Ward Laboratories, one of the leading agriculture soil testing labs in US. So when their results are ready, they flow directly into the farmer's dashboard automatically. No PDF, no manual entry required, so no transcription errors. Full soil chemistry, pH, CEZ, organic matter, nutrients, texture, it just appears in the app. So, and for the remediators, the workflow begins with creating like a project record. So they enter the site address, the site history, and any non-contaminants like PFAS, lead, arsenic, hydrocarbons. So they order a contamination grade testing package, so which is significantly more comprehensive than agriculture soil chemistry. Same containers are delivered for the defined grid point sampling across the site. So when results come back, the contamination concentrate at each grid point flow automatically into the project dashboard. And the system generates a baseline contamination map, spatial visualization of concentration levels, depths, and the mobility data. So from the moment, so basically from the moment a farmer sends a sample or the remediator sets up a project, the data is flowing automatically into the structured system. So there is no PDF sitting, no spreadsheet, no juggling. And then what happens? So we'll go to the next slide. Yep. So here, once the soil chemistry is in the system, the A interpretation engine runs. It reads the full chemistry profile and cross-reference it against our biochar feedstock library, which includes like properties of wood-derived, crop waste derived, seaweed-based biochar at different pyrolysis temperature without activation treatments. So for a farmer, what they see in the app is like a plain language summary of what their soil is missing and why their yields have been underperforming. Then a specific prescription, for example, like 1.5 ton per acre of wood-derived biochar, pre-charged with, like let's say, compost of 1 to 3 ratio, applied before spring planting. Expected outcome will be like improved water retention in year one, better nutrient availability ongoing, and they can place the order directly in the app. So we prepare the blend to spec and ship it to the farm. There will not be any intermediaries. So, and for the remediators, the output is more complex. So they received like a contamination map with concentration levels by grid point, a specific blend recommendation, for example, like pine biochar enhanced with iron oxide for heavy metal zones, plus like a microbial inoculants for any hydrocarbon affected areas. So variable application rates by zone, like 3 ton per acre in central contamination zone and 1.5 ton acre around the perimeter, and like a exportable treatment design document that can be submitted directly to the regulators or included in a project report. So order place, chain of custody, delivery with like a full feedstock certification. So that's what happens on the step 2. Can you go to the next slide? So here comes the verified track, what we changed. So this is what I consider the most strategically important part of the platform and the part that's most neglected in the industries right now. So there is a massive accountability gap in soil remediation and soil health improvement. People apply things, they hope they work, but they are rarely systematic and verifiable record of what changed, when, and how much. So that gap is what prevents farmers from accessing carbon markets and what exposes remediators to regulatory and liability risk. So our verification workflow has 3 time horizons, like baseline captured before application, the soil test and contamination map are logged at the verified starting point, 30 to 90 days during the treatment, follow-up soil samples and GPS tagged field photos document the treatment in process. So then 6 to 12 months, the before and after comparison and the formal report. So for farmers, like a 6 month a follow-up test reminder arrives automatically. When results come in the gap, the app shows like side by side before and after. For example, like organic matter, like up from 1.8 percentage to 2.4, pH moved into like target range. So each data point is timestamped and GPS tagged automatically. And critically, the carbon credit evidence base is being built real time. So with zero extra effort from the farmer, if the site is eligible, there's like a one-click pathway to carbon market documentation. For the remediators, GPS tagged photos are every grid point after application, 30, 90, and like 365 days following up follow-up samples flow in automatically and scheduled intervals. So the system generates like trend charts showing like the contamination decline over time by grid point. The final report is like timestamp, GPS referenced, and a chain of custody documented. And it satisfies both regulatory report requirements and the carbon registry submission standards simultaneously. Next slide, please. So here comes the evidence engine. So we call it like a evidence engine because every test, every application, every outcome is verified and stored in a structured, linked data architecture. So let me walk through the three pillars. So there is data collection, all soil chemistry and contaminant data flows via WaterLab API. No manual PDF entry, no transcription, no version control issues. So UPS tracking is linked to each sample. So we know exactly when the sample was collected, when it is arrived at the lab, and when the results were returned. Every data point is timestamped from the moment of the first contact. And then the field documentation, where the GPS tagged application photos tied to the specific grid points and timestamps. So before, during, and after soil test linked to each other within the project record. Contaminant trend charts generated automatically as new data comes in. So the chain of custody records for the biochar itself. It's from the feedstock source through the pyrolysis through the delivery. And then the verified output, a complete remediation report that is regulatory ready, like a and then like a carbon registry evidence package that can be like submitted to isometric bureau or other verification bodies, a client facing before and after summary, and all of the data feedbacks into like a AA model. Every new soil test, every outcome, every performance data point, which makes the next remediation smarter. So we are building like a proprietary soil intelligence data set that compounds in value over time. Next slide. So, here is where the data comes from. So we have like a three pilots, like Iron Hill Farm. Which is having like a highly acidic and several limit crops diversity. And then there is like Sunny Meadow Farm in Bridgewater, and then Stewart's family farm. So we have these three pilot plots from which we are currently like collecting data on improving our AI model. Can you go to the next slide? So here's a complete workflow. So it's like a one platform for both use cases. And so there is like the one is like the order test. The customer opens the app, so we handle the logistics. The kit arrives, and sample goes to the WhatsApp. Two is like auto ingest, result flow in directly. There's no PDF, no manual entry, no human error. And then three, a prescription. The platform generates like a custom biochar blend with application rate, amendment specifications, and timing guidance. Four is like apply and track, then GPS track photos, then trend charts, and 30, 90, 365-day milestones all are captured automatically. And five is verify and report, and regulatory documentations and carbon credit evidence generated for the same data set. So so this is a kind of an app, and this is how we track each and every instances of the process. Now, like I would like to let Narasha talk about the rest of the part.
Thanks, Bluevin. I know that we're just about a minute away from closing this presentation, but just thank you so much for joining us. I think that, our platform does three things very well: diagnose, treat, and verify. As we verify outcomes, we're looking at GPS tag data, trend charts, and regulatory grade reporting. And so, yeah, I think that there are quite a few questions, so I'll just stop there. And thank you so much to everyone for joining. And let's have an exchange. Jim or Katie.
Well, thank you very much for this presentation. Very interesting stuff. We do have some questions in the chat that I will read here. Plus, if you have a question here now, please feel free to raise your hand. Otherwise, drop it in the chat and we will have, we'll ask it that way. But we'll get to them in order here. And so some please, if this, I don't read your question here because some more of a statement. You can read those in the chat. But the first one comes from our own Dwayne Stenlin, formerly of Minnesota Department of Transportation. He writes, how much biochar pounds per unit area for heavy metals, PFOS, or PAH? Is the same applied rate or different based on the pollutant loading?
As this is a really nice question, and actually, different rates are needed, no? So as application depends of the contaminant type, the concentration, and also the soil conditions. That's why Super Biochar first evaluate the soil conditions and the contamination levels. Not all the sites are the same, not all the fields are the same. You need to do deep evaluation. After you apply our biochar, you need to verify its behavior on the soil. So just to give like an approach, for example, if we have heavy metals problem in the soil, typical rate could be like 2,000 to 5,000 livers per hectare. If this contamination is too high, it could be like 10,000 livers per acre. Sorry, it's not hectare, it was acre. Yeah, but yeah, evaluation is needed.
Okay, the next question we have, does all biochar provide slow release fertilizer effect inherently in its raw form? Or do you, or this is verbatim here, or do additional properties need to be defined beyond referencing to biochar as a singular material to differentiate biochar capable of delivering nutrients from a biochar capable of capturing nutrients?
Yeah, definitely not all biochar is a slow release fertilizer. That's why, because biochar, some biochar is really rich in nutrients, other ones are poor in nutrients. And here we have, for example, some example, manure, bone, sweet slush, algae biochar. Normally those biochars are rich in nutrient, and you can say for that biochar, hey, this is a really nice biochar with a nutrient releasing properties. Another biochar even can capture nutrients for the soil. For example, wood biochar, coconut shell, rice husk, these are poor biochar in terms of nutrients. Even, for example, the temperature that you do that pyrolysis, if you paralyze biochar in low temperature, it has more concentration in nutrients compared with the one that you use really high temperature to paralyze those materials. So yeah, in our analysis, we need also to consider these properties, the agronomical properties in order to have a better understanding of the material, the biochar that you apply in the soil.
Can't hear you, Jim.
Jim, we lost your sound, yeah. If not, I can take over reading the questions as well.
If I
Still
can't
not.
be heard,
There you go.
yeah.
We can hear you now. Perfect.
Oh, I gotta use my voice. I was thinking these things. Okay, the next question was the state of biochar for soil amendments today, in my opinion, is well aware that consistent composition is one of the most important selling features to farmer. Isn't consistency becoming common? Oh, Sarah, if you're talking, there you go.
I can answer that. So it's a great point.
Yeah.
And yeah.
Go ahead, Bluven.
Yes. So it's a great point. I agree with you. So consistency has absolutely improved like across the biochar industry. So with standards like new ANSI testing framework and more lab access in North America, producers are like much more aware that composition, stability, and contaminant thresholds matter, especially for the farmers. So yes, consistency is becoming more common at the material level, but here is a distinction we focus on. So there's difference between consistent biochar and site-specific biochar applications. So a producer can deliver a consistent product, the same feedstock, same pyrolysis temperature, same general chemistry. That's like a good baseline. What is still less common is tailoring that material and the application rate. So which is to like specific soil chemistry, specific like crop nutrient demand, and local climatic condition, existing organic matter level, and then the contaminant profile if present. So the consistency of product is necessary, but the precision of prescription is the next layer. So our focus isn't just on producing like a consistent biochar, it's on matching the right biochar at the right rate to the right soil conditions, then verify the outcome. So I would say the industry is maturing, so which is like a positive thing, and what we are building sits on top of that maturity.
Yep, Jackie, I see you nodding your head. I think you got your question answered, and she is a alumni of the Char Talk series herself. And this is coming from Kevin Bernard in Maine. Has anyone tried using biochar as an oil absorbent material as a replacement of using speedy dry or kitty litter for oil spills? Says I've been using biochar to clean up oil in soil, and it works well.
Hi, it's a fantastic point. I guess yeah, biochar has absolutely been studied and used as an oil absorbent because the surface area will go up to like 150 meter square, and like a porous, like it's a porous carbon structure, and biochar can act very much like an engineered sponge. So it absorbs hydrocarbons effectively, including diesel, crude oil, and petroleum residues. In fact, compared to like traditional adsorbents like clay-based kitty litter or like speedy dry, biochar often has like a higher surface area and greater adsorption capacity. The added benefit of is like the supporting microbial degradation. And so yeah, the clay adsorbents typically like they just trap the oil, they don't contribute to biologically breakdown. So biochar on the other end can serve as a habitat for hydrocarbon degrading microbes, so which can accelerate the remediation in soil environments. Now for like large open water spills, like you would need like a specifically engineered, often hydrophobic modified biochar, and like a specific regulatory standards that would apply depending on the jurisdiction. But for soil contamination, like what you mentioned, so there is growing research and real world use supporting exactly like what you're seeing. So yeah, your experience aligns with the science.
Thank you, Blumen. And the final question I have here is, has biochar been used for remediation of dioxins?
Yes, has been used, and especially in scientific level. For example, if you compare biochar usage, compare with PFAS, heavy metals in PAH, and dioxins is more persistent in the system, take times to remediate, and then even for scientific level compared to the other ones that I have mentioned is more difficult. So it's just the beginning of these histories in this aspect.
Fantastic. Thank you. Do we have any other questions in the audience here? Looking to see if for hands raised here. So
Loving it.
so could you let me see here. Looks like the one of the questions or issues I'm looking at or thinking about is, like you said, one of the issues we have in Minneapolis is the arsenic issue. Lead, it's everywhere because of not both lead paint, leaded gasoline in the past, but particular interest was on the arsenic and the immobilization of arsenic. And it was very interesting to see how your treatment of the biochar specifically for that. And I was just wondering if you could just say a little bit more about that as far as specifically to heavy metals and arsenic in our condition.
Sure. And then this is also a problem in Connecticut. Incredibly, it's the same. So arsenic is interesting because we need to look at the soil pH. Because if you change too much the soil pH, you can immobilize the arsenic, precipitate it, and after, if you increase too much the soil pH superior to 8 or superior to 7.5, we remobilize it again. One strategy that has been really used, even do not considering biochar treatments, is iron, because they are really, they have a huge affinity between one another in complex those things. But also when we added biochar and iron, enhanced biochar with iron, the result has been so great. So this is one technique that you can use. But also you need to look at how is the soil behavior in terms of pH. Because if you change, if this soil during the time, if you apply the treatment, if you do not check and continue monitoring the soil, it can be available again in the soil solution.
Jim, you're silent again, but I know he was saying that's amazing. A lot of good things that you just said, and thank you, Sarah. I know we have 3 minutes left, but Kevin's got his hand up, so we'll go to Kevin, and then I know Nick had another question. So, Kevin, if you want to jump off mute, and ask your question, feel free.
I just quickly would like to know what you're doing with the contaminated biochar when you actually use it for absorption.
Yeah, this is a really nice question, Kevin. Currently, one of the usage is to imagine, for example, some biochar is used as a filter, no, to discontaminate water. So you can use it in the construction materials. But of course, there is some contaminated that is so huge there is so toxic for to be in contact with people. So those things need to be studied a little bit deeper, and yeah, introduce like microorganisms to degrade it. And the research needs to be done in this aspect, and you need to go deeper. But yeah, one of the main solutions is choosing the construction materials, because it can be immobilized in the constructions for years or thousands of years.
Thank you. That's great. That makes sense. Nick, go ahead and unmute yourself. I know you put your question in the chat, but you might as well just go ahead and ask that as well.
Yeah, I'm just curious what the actual application of AI within your modeling is. The way I heard it described is cross-referencing different tables of properties and input values, but AI is a deeper term than a VLOOKUP table in an Excel file.
Yep. So that's a fair question. So if all we were doing was like matching soil types to like a static recommendation table, then yes, that would just be like cross-referencing, not AI. Our system actually goes beyond that in like three main ways. Like one is like a multiple variable optimization. It's not just like lookup. So we are not mapping like soil A to biochar B. What we are doing is we are solving for multiple interacting variables simultaneously, like the soil chemistry, crop nutrient demand, and biochar material properties, application rate, like cost targets, carbon performance thresholds. So that becomes like a constrained optimization problem. So the system searches for the blend and rate the best satisfies multiple objectives, not just like a rule table. And the second thing is like it learns from the outcomes. So the model updates based on the structured field data, like the yield response, pH shifts over time, nutrient retention, contamination decline rates, water retention changes. So as like more projects are completed, the system refines weighting parameters and it improves the predictive accuracy. So like a lookup table does not adapt, an adaptive model does, like an AI model does. And the third one is like a probabilistic recommendation. It's not like a deterministic output. So instead of saying this always works, the system like assigns confidence intervals, and it's expected outcomes as well. So that's the importance in important in like a soil system where variability is high. So basically we are not using like a large language model to design blends. Like LLMs are useful for documentation and user interaction. They're not the right tool for the chemical optimization. We are using structured machine learning and optimization logic on the quantitative data sets. So that's what we are doing.
Thanks. Yeah, that emphasis on the machine learning is what I was looking for.
Yeah, that makes a ton of sense. Thank you, Leuven. And then MCM and 24. I know Natasha had asked for some clarity on the question, so if that person wants to jump on and ask their question, feel free as well as we kind of start to wrap this up. Still on, but still muted, so in case you're speaking, we can't hear you. But again, the question was totally support this effort, as you know, but I wonder how do you respond to those who point out the amount of carbon a given biochar operation sequesters is nearly meaningless. Those are some strong words, so would definitely love to be able to hear that from that person as well, so we can all learn. But we may need to do a follow-up. One more time, just calling MCMN24 to the front of the house. Otherwise, Mark, I saw you came off mute. So did you have any last questions before we jump off? Nope. Okay. And then Jim F, how do we use this service? So Natasha, will jump that one back to you.
Well, that's a loaded question.
Yeah.
How do we use that? How do we use this service? I mean, reach out to us. We're still we came out of stealth in September. We're in 2 accelerators. We're still piloting. We're going to be piloting beyond Connecticut, but we do provide, we're in this together, right? So one for all for one. So let's talk and let's figure out what your needs are, and we're happy to consult on that.
Yeah, I think the biggest thing would be if somebody has the need to remediate a site and they are considering doing it with biochar, that you would be the people that they would go ahead and reach out to start that conversation as the leaders in the field. So that's exactly what you said, but just in a, selling it for you kind
Yes.
of way. And then Jackie asked, are you documenting the benefits that remediation also brings?
Yes, all our pilots has been documented. First, the beginning, we track the soil performance, we track the problem, we track the solutions that we are giving and the results.
Perfect. And then John, I know we're over, so I'll wrap this up with one last thing. But John had just said, John Adams from Appleton had mentioned that, it's recently come out that North Carolina is extremely contaminated countryside due to their carpet industry and heavy PFAS in those compounds. So, definitely considering the use of biochar as an adsorbent material for trapping and sequestration could be a viable approach. And, you're exactly right, John. I definitely heard that recently, and that was the first thing that popped into my mind. So I'm sure, the Super Biochar team as well. So, and Ethan, consider connecting with a company, Earth Optics, which has been really pioneering this work in identifying and quantifying soil and health parameters. And Ethan is a PhD at the University of Minnesota, also a member of MNBI. So I think he's saying that could be a good connection for you guys. And Ethan, if you have a contact there, maybe you could introduce Natasha and team as well. In the meantime, we'll go ahead and wrap this up. Natasha, Sarah, Bluevin, any last comments you want to say before we let everyone go?
No, I just want to thank you. I just want to thank you. I think Sarah and Bluevin hear me say this a lot of the time, but Super Biochar would not exist without them. You know, Sarah's scientific prowess, Bluevin's technical expertise. You know, it's remarkable, their expertise. And, you know, we're learning as we go, which is why we're still, you know, thankfully out of stealth, but we're still wanting to have conversations and learn and also, you know, work with your audience and beyond. But yeah, thank you for
Wonderful.
having us.
Yeah, thank you so much for sharing today and, you know, for all the amazing work you guys are doing. Of course, remediating soil is a huge task and nothing that is done lightly, but something that is definitely needed. And of course, we saw that from the large turnout of people that were interested in RSVPing. And I know we'll have a lot of people watching this on our YouTube channel. So again, we'll wrap up today and say thank you so much to Super Biochar. Thank you so much to everyone else who joined. One more plug for MNBI, Minnesota Biochar Initiative. This will go on our website and via YouTube and will live on. So everybody can feel free to watch this as many times as you would like. And then if you'd like to become a member of MNBI, please go ahead and do that. And in the meantime, it is in the chat. But if you do have any questions or you maybe want any follow-ups, I know Natasha had put her email in there, I believe it was, for direct follow-ups. But also, we have an email which is admin@mnbiocharinitiative.org. So feel free to reach out and we can make any necessary connections. So I would say that's it for us today. I hope everyone has a wonderful weekend and we will speak to you in a month for another amazing biochar talk. So we'll be getting that information out soon as well. So thank you so much. Have a wonderful weekend. Take care and we'll talk to you all soon. Thank you so much.
Thank you so much, everyone.
Bye bye. Thank
Thank you.
you.
Bye-bye.